Hello everyone, we are Yin Force. Today we're going to talk about application of differential equation in real estate. Now, let's talk about the members of the group. There is me, Muhammad Amrudin bin Muhammad Azhari. Next we got Shakila Alia binti Mazari. And last but not least, we have Muhammad Haris Bahan bin Hussein. So, what is real estate? Real estate is a property. It could be land or any permanent structure, and also it could be natural or man-made. So, population growth is one of the main factors in building real estate. We have a problem. Mr. Asri is an urban planner. He wanted to build a neighborhood in Sabah. It is either in Kota Kinabalu or Sandakan. So he need to know the expected population in 2040 to help him to choose between the two.
Okay, on information that we have on Kota Kinabalu. Kota Kinabalu have 589,000 of residents in 2015. In the following 15 years, it has experienced a rise of 2.26%. Mr. Asri is interested in finding the expected population of Kota Kinabalu in 2040. Okay, to explain the population growth in aspect of differential equation, we assume that n is the size of a population for any living thing, which tends to grow exponentially. Okay, by this, the rate of population is the derivative of n over time, which is the n over dt, and it always obey the differential equation. The n over dt equals to kn. K is the constant of proportionality, and it must be always greater than 0. Okay, by using the method of separation of variable, we move the n term into one side and the t term in another side. And then we integrate both sides. We will get ln n equals to kt plus c. By using the exponential rule, we will have exponential of ln n equals to exponential of kt plus c. And then the solution for that is n equal to e kt plus e of exponential of kt plus c. And then we substitute ec with a. A is the initial n, and the initial of n. And then we will get the general solution for population growth, which is n equal to a times the exponential of kt. Okay, moving on with the problem. Our equation right now is nt equals to aekt. Nt is the size of population at time t years. And our a, which is the initial value of n, which has been mentioned before, 589,000. Okay, the number of population after 15 years is also mentioned before, had an increase of 2.26%. Okay, so we calculated this by getting the increase in population plus with the original total, and which we will get 602 and 311.4. We round that off because this is the total of people into 602 and 311. Okay, to find the value of k, we substitute all the given values into n in time 15 years. So we have 602 and 311 equals to 589,000 times with e of 15k. So e of 15k is equals to 602 and 311 divided by 589,000. which is 1.0226. So we use again exponential rule. We ln both sides of the equation. So ln E15k equals to ln 1.0226. We get 15k equals to ln 1.0226. So we divide ln 1.0226 by 15, and then we get the value of k equal to 0.00149. Okay, so our equation right now of NT is equal to 589,000 times with exponential of 0.00149k. Okay, so Mr. Asri is interested in the expected population of Kota Kinabalu in 2040. So by subtracting 2040 with 2023, we will get the T equals to 17 years. So we put the 17 years into the equation, which n in terms of 17 years equal to 589,000 times with E 0.0149 times with 17, which we will get 604,109.929, which we will round off because we are counting the people. We will get 604,109.
Let's move on to the information on Sadakan. The number of population in Sadakan in 2023, 642,000. For the next 15 years, population have increased by 1.74%. Mr. Asri need the expected population of the city in 2040. So we are going to use the same formula and method just like we already calculate for Kota Kinabalu, but we will change the information that related to the Sadakan. The percentage of population have increased for the next 15 years is 1.74%. We can calculate the number of population after 15 years, that equals to 0.0174 times with 642,000 plus with 642,000. That equal to 653,170.8. So the number of population after 15 years is 653,170. By using the formula of n equals to a times with exponent power of kt, we can get the value of k, where n is the number of population after 15 years, and then a is initial size of population with year 2023 correspond to t equals to 0, and then the value of t is 15. After that, insert the value to the formula and we're going to get the value of k. Since we already get the value of k, we can calculate the number of population in 2040 by using the same formula n equals to a times with exponent power of kt. So we need to know the value of t, that equals to 2040 minus with 2023, that equals to 17. By using the formula, n equals to 642,000 times with exponent 0.00115 times with 17. So the number of population in 2040 is 654,674.
Okay, so for the conclusion of our problem, so in comparing Kota Kinabalu with Sandakan for Mr. Asri project to build a neighborhood, by comparing the expected population in 2040, we would suggest that Mr. Asri build a neighborhood in Sandakan as it has a greater expected population than Kota Kinabalu. Okay, so for the overall conclusion for our topic, which is the application of differential equation in real estate, I want to say that differential equation provide a powerful mathematical framework to predict a population dynamic in the real estate sector. By solving this equation, it will help real estate professionals, urban planners, and policymakers to get valuable insight of the population trend and also the future of population trend. Thank you for watching this video. and like and subscribe if you like the content. Thank you very much.